right, so yesterday we wrote down some steps for the procedure for Lewis structures, right? All right, so you were not here. Get them from somebody. So number one, I'm just going to write valence electrons. We said we had to do what? Total them all up. Number two, we said we had to determine the what? Central atom. Number three, we said we had to do what? All right, so around the central atom. All right, and number four, we didn't get to number four, right? Number four, place the electrons from step one around each atom in the diagram okay, place the electrons from step one around each atom in the diagram until everyone has 8 electrons. It must total the number of electrons from step one. So if you add up 32 electrons, you're placing 32 electrons around each of those atoms until everybody has 8. It has to equal what you got from step one. You can't exceed what you had in step one. You can't have less than what you had in step one. So if you have 8, you can only put in 8 dots total. You have 32, you put in 32. You have 40, you put in 40. Now, the catch is, if everyone does not have 8 electrons, we have to rearrange until they each have 8. Now, you'll notice I put that step in brackets. That's because that step is for multiple bonds. We said yesterday multiple bonds for what kind of bond? Multiple bonds for what kind of bond yesterday? Other than Eileen and Belong, the rest of y'all should be able to tell me. That's right, double bond and triple bond. So to start with, we're not going to start with the stuff that I wrote there in that weird, funky yellow orange color. Okay, we're going to start easy with the green. And then we'll build towards the yellowy orange color. Next. Today and tomorrow would be work day. Today would be the worst day out of the two. Okay? Yep, everybody has to have 8. There's one exception we're going to learn today. We'll probably wind up learning no more than 2 total for the week. All right, are we all caught up? Looks like everybody's quit writing. All right, so to start, we're just going to do an easy one. We're going to do CCl4. Okay, CCl4. Now, the first thing we have to do is add up the valence electrons, right? So, C and Cl are added up a lot like we added up a math. And sometimes when we get to benchmark, it causes issues for people because they're like, huh, I forgot how to add up a math this fall. We've been doing those electron things for so long. Works the same way. How many chlorines and how many carbons we have? Well, carbon we have how many? Okay, How many chlorines do we have? We have 4. Now, the electrons. Several people in first period wanted me to refresh. Well, before I refresh, I think you could just flat out tell me how many electrons carbon has. Okay, I really like the 4. The rest of those numbers, need to invest alpaca. Oh. Why did we write down at number 1 yesterday? I realized we shorthanded that today. What did we write down yesterday at step 1? Valence electrons. So what did we say valence electrons were? Outer shell electrons. Okay? So, in case you forgot, because if you can't do step 1, we're toast on Lewis structure. Okay? Everybody in group 1 has how many outer shell electrons? Everybody in group 2 has? And then group 13? 4, 5, 6, 7, 8. So carbon would have how many? That's why I like the 4. Chlorine would have. Why did I say 14? Oh, okay. Well, I don't know why you said 14. But it is in group 14. Maybe that's it. Oh. Okay. So those of you who said 4 electrons, and then those of you who said 7 electrons are right where I wanted you to be. So those of you who didn't, are we okay with where we got those numbers? Okay. So 1 times 4 is 4. 7 times 4 is 28. And then we add just like we always did, and we have a total of 32 electrons. So in our Lewis structure, we're going to have 32 electrons or 32 dots. Remember what I told you? These are like dot diagrams on steroids. So where we had 8 dots before, now we're going to have 32. Huh? Sort of. Not quite. So, next we need the central atom. So, based on the 2 rules I gave you yesterday, who would be the central atom out of these 2 choices? Who is by itself in only 1 atom? And C will be the central atom. So, we're going to put C in the middle. Now, step 3. Place all the other atoms around the central atom. In this case, I have how many other atoms? I have 4 chlorines. So I'm going to place the 4 chlorines around it. If I only had 2, I'd place 2 somewhere around it. If I had 5, I'd place 5 around it. If I had 3, I'd place 3 around it. But they go around. Okay? They don't go in a chain. I don't put chlorine, 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 chlorine in a line. Okay? Everybody with me on that? Okay. So, chlorine, 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 chlorine. Everybody good on steps 1, 2, and 3? All right, step 4 is where we have the hard part, blending single, double, and triple bonds throughout the day. So, step number, all right, step number 4, if you're writing with a pen, and you do not want to be yelling at me about whiteout, stop writing, okay? If you don't like to erase with your pencil, stop writing for a minute. Now, we need to draw in how many dots? 32. All right, I draw on the central atom first. Some of you will, some of you won't. It's okay. You can draw your dots wherever you want to in just a minute. I draw on the central atom first. So, 2, 4, 6, 8 dots. Now, once I've drawn my 8 dots on my central atom, I am clearly not at 32 dots. So where am I going to draw some more dots? Okay. 10, 12, 14, 16, 18, 20, 22, 4, 26, 28, 30, 32. Uh-huh. It will be what we call an expanded octet, and there would be 5 or 6 possibly sticking off of the C. Okay? Not right now. No, not yet. Hold on, I'm not done. I mean, you can, but don't yell at me if you have to erase or use whiteout. Okay? Now, the two rules you have to ensure that you follow. Okay? Does everyone have 8 electrons and same electrons in step 1? Okay? This part where I just wrote this, back, you're right. Just don't draw the dots yet. Okay? So, when I go back to count, do I have 32 dots drawn in? Yes. Well, I met that rule. Now, I need to check to see if I have 8 dots on everybody. This is the part that's going to cause our issue when I get down here to these double and triple bonds. Okay? This is the one that causes the issue in the homework tonight. 2, 4, 6, 8. Chlorine's good. 2, 4, 6, 8. That's chlorine's good. 2, 4, 6, 8. 2, 4, 6, 8. All my chlorines are good. Carbon. 2, 4, 6, 8. Carbon's good. Now, what are these electrons right here doing with the carbon and the chlorine? They're sharing. So, since they're sharing, we do not draw them as dots. We draw them as a line to illustrate that those electrons are being shared between the carbon and the chlorine. Okay? So, thank you, drawing. Okay? When they're shared, you draw them as a line. A couple vocabulary words for you. The dots are called, they're called lone pairs, non-bonding pairs, or unshared pairs. All mean the same thing. Electrons not involved in a bond. 9 times out of 10, you will hear me refer to them as a lone pair because that is the way I learned them when I was in high school. What my chemistry teacher called them, that is what I will call them most of the time. However, depending on the author of the text or the test question, if their high school chemistry teacher or college professor called them a non-bonding pair, that's probably what they still call it, or an unshared pair. They all mean the exact same thing. It just means they're not shared or they're not in a bond. Okay? Now, if those are unshared or non-bonding pairs, we call these shared pairs and bonding pair. Okay, and I'm not going to write a definition for those two because they mean the electrons are in a what? Shared pair. They're being shared. Is everybody okay with a line means how many electrons? 2, because we erased how many dots from a line? 2. Okay? Now, just to be clear in the drawing again, we have the rule that we have the same electrons in step 1. We counted. We had 32 electrons, right? Did everybody have 8? As long as you meet both of those rules, your drawing will be fine. So some drawings can be drawn more than one way. Most can't, but some can. And I'll show you one of those, at least one of those, before we get out of here today. Questions about how we did that? Does everybody have what they need off the board? Or do I need to wait? Everybody caught up? Because I want to show you one that's an exception. Okay? So if we draw water, water has H in it, and H is an exception. Okay? So, without a bivalent electron, how many different elements do I have? So, H and O. So, how many H's do I have? How many O's do I have? How many outer shell electrons does H have? How many does O have? So, I end up with 2 and 6 for a grand total of 8. So this time I have a lot less dots to draw. I don't have any 32, I've got 8. That's a lot less. Now, given I only have 8 this time, who is my central atom? Oh, remember, how many H's do I have? How many O's do I have? Which one do I only have one of? It's my central atom. Also, who did I tell you yesterday was never, ever the central atom? H can never be the central atom. Now, I told you when we drew this yesterday, but most of you don't remember. Some of you would draw it like this when you only had 2. Some of you would draw it like this when you only had 2. Some of you would draw it like this when you only had 2. Are any of those right or wrong? No. It doesn't matter to me which way you draw it. When you have your O as your central atom, whichever one you want to draw is fine. You just need to put the 2 H's around the H somewhere. You can even draw it in an angle if it makes you happy and make it look a little slanty. As long as you have 2 H's around it, it's cool. Okay? Now, given we already know the electrons are going to share here and here, do I need to draw dots to start with? No, I do not. I'm going to go ahead and start with lines. Now, hydrogen has what electron configuration? Yes, that's on the test. 1s1. How many electrons can an S sublevel hold? S can hold how many electrons? I heard several people with the right answer. 2 electrons. So, if an S can only hold 2 electrons, how many electrons can an H have on it at any given time? Can only have 2. Okay? So, H is an exception. Hydrogen can only have 2 electrons on it. Okay? Which means it has no dots or multiple bonds. If it can only have 2 dots, or 2 electrons, sorry, that line that's right there, is it 2 dots or 2 electrons? Right there. It's covered. Can never be the central atom. Cannot. Because it can only ever have 2 electrons. So it will never, ever be the central atom. It's in the notes that you're getting from 2. Okay? Double John. All right? It's in Jonathan. So, if I can't put any dots on H, because it can only have 2, where am I putting these 4 other electrons that we added up? Oxygen has to have. So, I might say 2 dots here and 2 dots here. Now, check your 2 rules. Did we put in the 8 dots that I added up? 2, 4, 6, 8. Yes, I have my 8. And does O have 8? Yes. Hydrogen won't have 8. It'll only have how many? That H, does it have 2? Does this H have 2? It's done. Question. All right, let's try one more. And I'm going to let you practice. It's not hard. All right, CeBr2. No, let's not do that one. Let's do one that, do the one that Andy was asking about, CCl5. All right? Because he asked about an expanded octet. All right, so how many P's are there? And how many C's? Or Cl, sorry. All right, how many electrons in phosphorus' outer shell? In group 15, there are 5. How many in chlorine's outer shell? Good. So that's going to give us 5. That's going to give us 40. What's around? Do the math in my head. 35, for a total of 40. All right, so who is my central atom? And how many CLs am I drawing around it? All right, so when I go to show my sharing, what throws people off? It doesn't matter. It has an odd number, yes, but he has what? It has too many electrons. How many does it have? That's 10. Okay? This is called an expanded octet. Okay, and we're going to do two of them. This is just one of them. All right? So this one will exceed the octet rule. So that one has 10 of our 40 electrons. So the other 30 are going where? On the CL. So there's 10, 12, 14, 16, 18, 20. Just keep going until you get to 40. Yeah, well, it'll be 30 because you already did 10. Okay? 2, 4, 6. Yes. Okay? Now, when you finish that, does everybody have 8? Check. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. I just feel like I'm belonging here on 2, 4, 6, 8. 2, 4, 6, 8. Everybody has 8. But then on the central atom, can you check to see if it has 8? No, because it's an expanded octet, so it has more. So everybody has 8 except P. And then check to make sure you had 40, which I just did, and we had 40. So that one has what's called an expanded octet. We're going to do one that has 5 and one that has 6. Those are the two we're going to do. There are others that I would teach if we were in an AP class, but technically expanded octets are not part of our curriculum, so I'm only throwing in 2. All right, let's draw 4. All right, let's do the TeBr2 I was going to do a second ago. Let's do SiCl4. Let's do 2H2F and one more. Let's do TCl3. All right, do those 4. And then we'll go multiple bonds. You guys that time to practice. I'm fascinating. Oh, does anybody have to go to the bathroom? When the administration comes by and says, do you need to go to the bathroom? It's still a bathroom pass. It's not a free pass to the bathroom. Okay. Oh, they did? Oh, good. I'm glad y'all aren't going to be locked down the rest of the year. No, because that would be a change. And chains are not part of our curriculum. I have a question. Very simple. Last question? No. We're back here. You sound terribly healthy. Let me just feed you this way. If I have no questions, are we done? Anybody want to draw one on the board? Go ahead. Just get a new screen and draw away.
Draw it out.
Yeah, you don't have to show the words, you draw. Somebody has a question about the electrons, we'll do that done. The electrons are two on a line. Yep. So remember, anytime you draw a line, that's two electrons are shared between the atoms. And now take the power source. Huh? It's just power source. That's great. All right. Other than Andy's handwriting, she's got awful. All right. So we can clean this up the pad, make his line a little easier to see. You made no mistake. Absolutely none. Everybody good on his? Anybody have an issue with what Andy drew? Doesn't matter if you rotate it sideways, if it's up and down, as long as you have two dots on PE, two set dots, which is there's 4 actual dots. And then you have 6 dots on each VR. Everybody okay with that one? Okay? Alright, who wants to do the next one? Go ahead, everyone. Why do you write it? Go beside it or something. It's fine. You don't have to go over here. Issues? Anybody? Everybody okay with that? All right, next. Got any volunteers? Go ahead, Brandon. All right. Hold on 1 second. Where did I say the dots could never be? Where you put those dots, they can never be on H. Yeah. Very good. All right. Last one. Any takers? Go ahead. Yep. Or you can just hit the board and two arrows. Give you a chalkboard. You have to write chalkboard or blackboard.
I don't know.
PL3.
Yeah.
Three. Yep. Any questions about putting them on? All right. Here's where the challenge comes in. Okay? Multiple bonds. All right? Yeah, go ahead and pack it. We're done for today. Really? It's 25 minutes before the bell? Back in the old days. No, not the old days. All right, first of all, multiple bonds are double and triple bonds. There are no new steps to being able to do this. Everything works the same way. We're going to use CO2 to illustrate how this works. Now, since the steps are the same, how many C's do we have? How many O's do we have? How many electrons are in the outer shell? And in oxygen's outer shell? So when we multiply and add, we get 4, we get 12, for a grand total of 16, correct? So who is my central atom? And how many O's do I have? Again, it doesn't matter where we draw them, both things are drawn side by side. So I need to draw in 16 electrons. I also tend to draw mine on my central atom first. So I tend to do 2, 4, 6, and 8. So once I put in my 8, I have 8 left to go. So what do you want to do? 4 and 4, or 6 and 2? Okay. So 4 here, 4 here. Now, tell me what my problem is now that I've drawn in my 16 electrons. This is the first one we've done where you didn't wind up with 8 on everybody.
Ms. Wall, can you send me a manual to come and change mine, please?
Sure, Miss Moore.
Thank you,
You're
Ms. Wall.
welcome.
I think
Anytime.
you'll love the email too.
Oh, I'll have to read that.
Oh.
Ah. Does she know you don't ever wear that shirt? I don't. So, if we look at the CO2 there, all right, if we flip back to any of your first Lewis structure, everything you drew here had 8. You didn't have to think about it. Y'all just slapped those dots in because you knew everybody was going to have 8, didn't you? Just put them in. They were going to have 8. You didn't have to worry about anything. Now, are they all going to have 8 in the homework tonight? No. You're going to have to figure out who does have 8 and who doesn't have 8. On the quiz Thursday, you're going to have to figure out who does have 8 and who doesn't have 8. Okay? You didn't think I was going to make it that easy that you just had to slap in 8 dots. Well, it was a miracle, and you still don't have it all. Now, but I can have something to say about that, because I told her in my morning. What are we going to do to fix it? This is step 4, when I put in brackets. If everybody doesn't have 8, we have to fix it. That's right, because crap over. Isabel knows what I did. I didn't mean to make it go away. I'm getting ready to put it back. I did not mean to erase the stupid structure. Let me put it back. Apparently when I drew a circle around it, and then I accidentally touched the board, I erased everything I did. So let me put it back. Okay? So, let me not do that again. Now, when you have this, okay, it would be really easy if I just said, oh, dang, 16, you still don't have 8. Boom, 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 boom. I got 8 now. But what's the problem with that? No, 16. I only have 16. And I have how many now? And some of y'all will do that on the quiz and the test. And I just walk along my pen and go, minus whatever. Okay? There's no partial credit in this. So you can't just draw in extra dots. Okay? You said there were 16. I can't draw more dots. We already drew in 16. All I can do is rearrange. So I want you to envision kindergarten, first grade, second grade, back in the days when we were all nice to everybody. Not high school. Okay? Some of us are not too nice. Okay? You need to come to my house every now and then. I have a 7th grader and a sophomore. We don't share very well anymore. Maybe y'all are nicer to each other than my sophomore and 7th grader because they're not too nice. So, if they were listening, I'd say that to them, so it's not bad that I'm saying it to y'all. So, when I have these electrons here, oxygen only has how many? 2, 4, 6. Oxygen has 6 electrons, and O has 2, 4, 6, 8 electrons, right? So O is like 2. I need some help. Carbon's got is 8. And because this is back in the kindergarten days, he's going to say, I'll be glad to help you out. So, if carbon takes its 2 electrons from there and puts them here, does that help the oxygen? Yeah. Now, oxygen has 8, but carbon only has how many? 6. So that doesn't help anybody, right? So, where can the carbon put its electrons to help both? Well, right here, they share electrons, right? So if C takes its electrons from here and puts them here, now they're sharing the electrons, and carbon keeps its electrons, but yet it shares it with oxygen. Okay? So now O has 8 electrons because it has 2, 4, 6, 8 electrons. Okay? Now, O on this side only has how many electrons? So, the carbon says, I can help you out because I'm nice that way. And it says, I'll just take mine and I'll share those with you So that now carbon has 2, 4, 6, 8, and O has 2, 4. So now everybody has 8, and do I still have 16?
Yep.
2, 4, 6, 8, 10, 12, 14, 16. So everybody has 16. Okay? Everybody got it? Now, let's say for a minute, if I go back, a second ago, I can't remember who said it, but I said, y'all want, well, I had 8 drawn in here. That's right. Let's say that Andy said, I want to do 6 and 2 instead of 4 and 4. Okay? So this O has how many? And this C has how many? And that poor O has how many? It should have left out in the cold 4. It needs how many too? It needs 8. Can we help it get 8? How can we help it get 8? Take it from here and put it there. And so now the C has 2, 4, 6, 8 still. And O has 6. So it's almost there. So what am I going to do here? Take that out and put it there also. So now this one has 8. This one has 8. And this one has 8. Now this has a name. These two things are called resonance forms. And both of those would be correct. Okay? If it was an AP class, you'd calculate which one is more likely to form in nature, but it's not an AP class, so we're not doing it. That's well past what I would ever think about this in high school. I think I'm going to Resonance form. RESONANCE. Because you can draw it 2 different ways, and both are correct. We call them resonance forms. Now, I graduated from Northeast College State, which is in Hackensack County. You ever heard of Lucas State University? It's out there. It's in North Carolina. Yeah. It's now a 2A school. When I was there, it was 3A, and it eventually became a 4A school before they built another school in the county. So there was only one school in the county at that time. All right. Let's see if you could draw. Nope, not yet. Hold on. You got to do polyatomic ions, and then you can draw. Before I forget this. All right, polyatomic ions. You guys should remember there's a group of atoms with a common charge. All right, and since we're doing, let me say, let's just do the one I did the first year. PO4 minus 3. I need one with an odd number. Now, polyatomic ions, first of all, can have single, double, or triple bond. Okay? So don't assume that because it's a polyatomic ion, it has to be a single bond. It can be single, it can also be double or triple bond. They work the exact same way. We do 2 things different. A, we got to do something with this minus 3, and at the end, we have to draw brackets around it. Otherwise, it's identical. So, how many P's do I have? How many O's do I have? I thought so. I thought you said 1. All right, how many electrons in phosphorus' outer shell? And then oxygen. So we get 5, we get 24 for a grand total of 29 electrons. Now, in a first-year chemistry class, y'all are never going to get an odd number of electrons. You can have an odd number of electrons, and if you have an odd number of electrons, the odd number is always on the central atom. But in a first-year class like ours, you are never going to have an odd number. You hear me say that? So if you have an odd number, there's another step or you have done something wrong. That's what we're going to talk about. So if you get this on your test or quiz, you have something else to do. All right, you see this -3 right here? What do you know that means? That means you gain 3 electrons, right? So if you gain 3 electrons, right down here, you say +3, which gives you 32 total electrons. Okay? That's the first thing that makes polyatomic ions different. The drawing of them is identical. There's nothing different there. Who's the central atom? How many O's around it? 1, 2, 3, 4 bonds. So that's 8 electrons, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Now, the final new step. All right, put brackets around the Lewis structure with an oxidation number. So you'll notice up here, 3. So when people see that, they know that it's a polyatomic ion. The number is what? -3. Yeah. If you don't have any trouble keeping them straight when you draw them tonight, you should be fine. Usually the hardest part for most people is memorizing the geometry. I told you, in the next 3 days, you have a high probability of getting it at least a couple of times. Now, I'll check those little short assignments with multiple choice and a couple questions. I like the longer ones. Yeah. It'd be 32. The total electrons would be 32 then. Because you have to add the 3 that are gained. Okay? All right, so I want you to draw for me. Yes. All right, try those 3. And then we'll go home. Try those 3. It's an oxidation number, +1. Polyatomic ion. All right, if there's no subscript, what did we say yesterday? Now, you cannot pick either one. But if there's only 2, and there's only one of each, does it matter? They just be side by side, right? So in that case, it won't matter. What? Yes, right. Yeah, most you just want to skim through most of the end, I think, for this kind of stuff. Yeah, this is probably like 10 minutes class for the rules that go with this. So with bonding, the early part class. No question. And then, all right, you've got 12, and you said there's a total of how many? You got 2 too many. Yeah, you put on the outside. That's 12. That's not easy. Yeah. Now, you said, you done that. Oh. You got 10. Time to electrons in that bracket. And then you do it. You got 12. So you got to take 2 out and then get 10. There's a great 2. Okay. Now, okay, yeah. And rate 2. Now, okay, if everybody has 8, you got 10 going. You got 10 going. So, 4, 4, 1. You have 12. You got 4, 1, 12. Okay. And then, right, 1, 11, that's 1. Okay. Go back. Oh. Planner, linear, polar, non-polar. What did you do? Look versus the what? Yep. Yep. So what is focal mean? They were all. So, a focal mean adding one to the book. These ones use focal is same as well. What you got? Uh-oh. Oh, more between myself and all. Yeah. That one has 12, both six has 10. That one has like 10 on both O's. Oh, that's right. That one has 10, that one has 10. If you have, instead of 16, you have 20, maybe more. And that one has 26, both six are 24. Why do those? Oh, no, but you got way too many dots. I took them back. Electron. So what? That's what. Yes, yes, yes.
Want to see if I could?
Yes, you can. Get right into your homework. Now, your homework tonight has directions at the top. Then say, draw the blue structure, tell the geometries and the polarities. What are you just supposed to do? Draw the blue structure. Okay, there are 14 questions. I want you to draw all of them. Now, this is our practice for in class tomorrow. When I say find the geometry, if you don't have any structures to draw or drawn, can you find the geometry? No, because I'm not giving you time in class to draw this. I'm going to draw NO2 up here. All right, so NO has 5 electrons, 6 electrons. Everybody got 11, right? This means you subtract 1, which is going to give you 10 electrons. So NO, 2, 4, 6, 8, 10. Take 2 here and share. Now we have 6 on this one. Take 2 more and share. 2, 4, 6, 8. 2, 4, 6, 8. Both of them have 8. 2, 4, 6, 8, 10. They both have 10. Bracket plus 1.
One double bond.
Yep.
The third one, two double bonds.
Yep.
And you can have 2, like 4. Okay, I see.
Yeah, like that.
How many? First grade. You didn't know homework.